Hi, 8th grade. Welcome to lesson 8.3, find volume of cones. By the end of the lesson, I want you to be able to say, I can find the volume of cones. Let's solve and discuss it. A landscape architect uses molds for casting rectangular pyramids and rectangular prisms to make garden statues. He plans to place each finished pyramid on top of a prism. If one batch of concrete mix makes one prism, or 3 pyramids, how does the volume of one pyramid compare to the volume of one prism? So one batch makes one prism or 3 pyramids. That means that one pyramid is equal to 1/3 of the prism. Focus on math practices. Make sense and persevere. If the artist mixes 10 batches of concrete, how many sculptures containing one prism and one pyramid could he make? Well, one batch of concrete makes one prism and 3 pyramids. So just to make, so say we use one batch and we make a prism. Then we use another batch and that gives us 3 pyramids. Let's draw this maybe. Okay, so use one batch and that gives me my prism. Then I use another batch and I get 3 pyramids. Ooh. That's not how you draw it. Miss Justinger. Okay. One, 2, 3. So now I've used 2 batches, but I want to make some prisms to line up with those. Now I've used, this is a batch, this is a batch, this is a batch, this is a batch. So I've used 4 batches to make all this. 1, 2, 3, 4. I could use another 4 batches, which would make 8 batches of prisms. And that would be 3 prisms per 4 batches. So then, let's see. I have 2 bags left, so I can use one bag to make another prism and another bag to make some more pyramids. So essentially, I can use 10 bags to make 1, 2, 3, 4 groupings, and I'll have 2 pyramids left over. Okay, example number 1. Find the volume of a cone. Kiara is filling a cone-shaped pastry bag with frosting from a cylinder-shaped container. How much frosting can the pastry bag hold? How can Kiara determine how many times she can fill the pastry bag? So you draw a cylinder to represent the container of frosting and a cone to represent the pastry bag. The volumes of the cone and the cylinder with the same base and height are related in the same way as the volumes of a pyramid and a prism with the same base and height. So 3 cones could fit in the space of 1 cylinder. Remember that the volume of a cylinder is equal to pi r squared h. So if a pyramid is just 1/3 of that, the volume of the cone is 1/3 of that. So the volume of your cone, this is the most important formula for cone, is 1/3 pi r squared h. Then we just use our steps. We identify the variables, plug them in, use the exponents, and multiply. So the pastry bag can hold about 20.93 cubic inches of frosting. The bag can be filled 3 times from the container of frosting. Find the volume of the cone, use 3.14 for pi. So remember, the volume of a cone is 1/3 pi r squared h. So I'm going to keep my 1/3 they changed 3.14 for pi. My radius is 1.5. We have to square it and times 4. I'm going to keep bringing down the 1/3. And 1.5 times 1.5 is equal to 2.25. My last step is to multiply. So I'm going to do 2.25 times 3.14 times 4 times 1 is equal to 28.26. And then I can multiply, because this is all fractions. So this I could put over 1 over 1. 3 times 1 times 1 is 3. So my last step is just to divide that by 3 and get 9.42 inches cubed. If you know the volume of a cone, how can you find the volume of a cylinder that has the same height and radius? Well, the cone fills up the cylinder if you do it 3 times. So you take the volume of the cone and multiply it by 3. We're going to skip example 2 because it's something that we should have learned in topic 7, but we don't really need it for right now. We can go back to it later. Find the volume of the cone given the circumference and the base. Remember that circumference is equal to 2 pi r. The circumference of the base of the cone is 6 pi inches. What is the volume? Well, in order to use the volume formula, V equals 1/3 pi r squared h, I need to know what radius is. So they plug in 6r for circumference and solve for r. Divide both sides by 2r, it cancels out. 2 pi, it cancels out. 6 divided by 2 is 3, pi divided by pi cancels out, so the radius is 3. So then we can plug that in to our equation. 1/3 pi, instead of radius we have 3, and we see our height is 13. And solve. Not going to solve A, we're just going to go right to B. Express the volume in terms of pi. So our formula of volume equals 1/3 pi r squared h. I need radius, but I don't have radius. I just have the height and the circumference. But remember, circumference equals 2 pi r. So if I know C is 16 pi, instead of C I can substitute 16 pi equals 2 pi r. I want to solve for r, so I divide both sides by 2 pi. Cancels out on the right, the pi's cancel out on the left. 16 divided by 2 equals 8. So the radius is 8. So now I go back and substitute into the formula. Volume equals 1/3, leaves in terms of pi, radius is 8 squared, and the height is 21. So volume equals 1/3 pi 8 squared is 64 times 21. Multiply across the numerators. Remember, you can always make these over 1. So I get 64 times 1 times 21 equals 1,344 over 3 pi. Last step, divide by 3. And the volume is 448 pi feet cubed. Okay, key concept. The volume of a cone is 1/3 the volume of a cylinder with the same base and height. The formula for volume of a cone is 1/3 big BH, where B is the area of the base, and here the base is a circle. So volume equals 1/3 pi r squared h. So remember, this pi r squared is the area of a circle. Okay, 8th grade, let's say it. I can find the volume of cones. Have a great day.